Hi, I'm Sabir again. Thank you very much for being watching this lecture, and I'm here with new lectures of tensor, stress, and stress. Especially, I'm a geophysicist, so I'm going to make this series of lectures only for geophysics and geodynamics, but I will make some lectures which will be consist of tensor, stress, and strain. And these lectures can be helpful for even other engineering or applied science students, for example, mechanical engineer, fluid science engineering, or physics, chemistry, something like that. So it doesn't matter whether in which field you are, but later I will discuss all about the geophysics and geodynamics. So before going through this, the basic properties of this geodynamics or geophysics is tensor, stress, and strain. So I decided to make a series of lectures all about that. So today I'm going to start with tensor. Tensor. So I'm pretty sure that you all about know what is tensor. The tensor is nothing but is a mathematical object or geometrical objects that describe a linear relation between between vector scalars or something like that, right? So you know very well. So it's a mathematical geometrical, it's a geometrical object and it's a linear relationship. So you must have to know all about that. So it's nothing. So it describes everything at a point that needs to be described that object. For example, here I can give you an stress tensor. What is stress tensor for an example, and what is electromagnetic tensor. Okay, so elementary example of such relations include the dot product, right? You know very well here, the dot product and cross product and linear maps. Vectors and scalars themselves are also tensors. So it's also important to us to make sure that vectors and scalars also tensor. The tensor can be represented as multidimensional array or something like multidimensional array. So I'm sure you must have known that is or is array and or is single array or is multidimensional array, right? So tensor is nothing but it describes every possible aspects of something. For example, stress. For example, we have a three-dimensional object, right? So in the figure we see here, it's a three-dimensional object, right? So for example, it's a general body and it's a minute, very minute, very small body here. So we zoom it. So we have here the x-axis here, right? And so this plane, and this is the z-axis and this is the y-axis. So this plane is xz plane, right? This plane is xz plane. So this plane is xz plane, and this plane is what is that, x yz plane, and this plane is zy, something like that, right? So the stress tensor describes everything or every state of stress in that body. For example, here in this plane we have sigma xx. If a stress that directs into the xy, and uh, it forces applied to the the forces per unit area that exerted to the x-axis, and that's why x sigma xx, right? And tau x that deviates from the x-axis, right? And tau yx, something like that. So it stress tensor is nothing the state of stress at a point inside a material in the deformed placement or configuration. So it's nothing but the state of stress point inside a material. So how many states of stress are available in a point of a deformed or configuration body? So it describes that. Okay, on the other hand, we can see, so we have here 9 components here of a stress sigma xx, tau xy, and tau xz, and something like that. So in diagonal matrices, we all have the sigma xx, sigma yy, and sigma zz. So these are the diagonal matrices, and all these are non-diagonal matrix components here, right? Yeah. So what is sigma xx? Sigma x is nothing but if a force exerted in the direction of x direction and is exerted to the x plane, that's why it is called sigma xx, and similarly it is sigma yy and sigma xz. And I'll make you understand every details points of that to the next stress tensor or stress classes or stress lectures. So I'm just going to make you understand what is tensor is about. So another example is electromagnetic tensor. So what is the electromagnetic tensor? Electromagnetic tensor is nothing but this strength tensor, Faraday's tensor, or Maxwell behavior is a mathematical object that describes the electromagnetic field of a physical system. So same thing, the electromagnetic tensor describes the uh, is a mathematical object, right? And it describes the electromagnetic field of a point, of a particular point, a particular system. So every detail state of electromagnetic field, it can be detailed, right? So it is the electromagnetic field. So these are the tensors. So we have to, why you do study this? Because number one, in quantum mechanics, in geodynamics, there are a lot of fields we do study. So for example, here in quantum mechanics, quantum mechanics. So two in geodynamics, geophysics, mechanical engineering, physics. So there are a lot of applications of tensor, because especially if we are interested in quantum mechanics, then tensor is obviously needed to all students or all researchers. So that's why we must need this tensor. So this is nothing. This is a tensor. So in next lecture, I'm going to make you understand what is the summation convention and what are some important things. Thank you. I hope you enjoyed this and you like the lecture. Thank you very much. And I'm going to see you on next lecture.